Hey folks, thanks for tuning in. I want to show you a thing that I made. It came out of a tool that I work on at Facebook called Comparison View, which is a data analysis app for performance data. So we collect data about performance, profiles, that kind of thing from client, server. We take a whole bunch of this stuff and aggregate it together. And then Comparison View is this app that lets you analyze that data. And we faced various challenges with it. It's got a lot of interactivity where you're like editing one thing and another thing is sort of changing in sync with that. It's got just a lot of different settings that then go into queries issued at runtime to different data sets, which are then combined on the client. It has sort of persistence, so we heavily put state into the URL so that you can then share it with somebody else who can then see exactly the same thing that you're looking at. And it's got a lot of functionality that's provided by partner teams, and so there's sort of these third-party plugins that have to do a lot of stuff in the app. And so because of those things, we've always hit limits with existing solutions for state management. Whether it's just using built-in React state or something like Redux, we'll hit like flexibility limits or performance limits, or just things where we find that code is sort of bug-prone the way that we would write it in another library. And so we've had to solve a lot of those things in a different way for this app, and we've extracted that solution into a library, which you can now use. And it solves three basic issues. The first is flexible shared state. The ability to have different things that are in sync at different parts of the React tree in a way that's really performant. Secondly, derived data and queries. The ability to compute things based on changing state efficiently and in a way that is very robust so that we can move quickly and not have bugs. And then finally, app-wide state observation. So for things like time travel debugging, undo support, persistence, logging, that kind of thing, the ability to just observe everything that's happening in the app from some component. And so we made this little library that does those things, and we call it Recoil. It's very minimal. It's just adding extra little ingredients to React to help with those things so that you can use just a little bit of Recoil in your app when you run into limits with whatever you're currently using. I'm just going to give you a really quick tour of how it works. So the first issue is shared state. Now I made this little demo app, and it's just this drawing canvas prototyping app. So you can have these things, and you can sort of put labels in them, resize them, drag them around. Just have these shapes on this canvas, okay? And so I'm just going to add a few of these. Right, okay, and I can just drag these around. Now, the way that we would structure this, the state for this app, using just React state, you know, I'm sure you can already imagine this. We're going to have this app component at the top, and in its state, it's going to have a list of item IDs. So each of those items that we drag onto the canvas is going to have an ID, and we just have an array of those at the top level of the app. And then once we have that array, we're just going to iterate over it, and we're going to render out a canvas item component for each item that's in that state. And then the canvas item, we have some more React local state that has whatever the state is for that item. So it's XY position, height and width, label, what shape it is, all that type of information. Now, the reason that we've pushed that state down into the individual item is so that when we drag, it is performant. Because if we had to re-render the entire app or the entire canvas whenever we updated this component, it would be much too slow to be interactive. We want to just re-render the individual component anytime we change its state and not have to re-render all of these other things that we see on the screen. So we've pushed it down the state into that individual component. And that works fine for the app that you see here, but once we add some features, then it's not going to work quite as well. So here I've added this sidebar on the left that has a list of items. So, you know, the selected item you see, when I move that, the information that's on that sidebar changes in sync with moving it. And then also I've got this inspector on the right, and that information changes in sync, and I can move it over here and it'll move and that kind of thing, right? And I can set the background color. So we'll just set that to maybe a nice white color. And once you have this situation, then you've got a problem with the previous thing that we saw, because you've got your canvas component over here in this React tree, and it's got all those items that are on the canvas. And over here you've got your list component and all the items that are over here on your list. And you've got this corresponding components for a particular item, like item number 2 here. And they're way apart, miles apart in the React tree. And so the normal thing you would want to do in React if they need to share state is to hoist it up to the common ancestor, but you can't do that here because the common ancestor has too much stuff in it to re-render while you're editing and moving that thing around. It would be much too slow to re-render everything up in that tree. So you can't do that. And the next thing you might try is, well, maybe we'll use React context. And so context lets you have a provider up at the top of the tree and then these two consumers that are listening to it, but nothing in between has to re-render. It's like a direct thing from provider to consumer. But that's not going to work in this case either. And here's why. We don't know how many of these items there are going to be. There's going to be like one individual piece of state for each item that's on the canvas. And so if, say, we had 6 of them like in this picture, we'd need 6 context providers, one for each item, because each one of them is going to need to update separately, right, in order to get that behavior where we don't have to re-render all the others. And there's nothing wrong with having a lot of context providers. I've seen an app that has over 1,000 context providers. It's not really a big deal. The issue is when you don't know how many, right? If you need to insert a new one, like when you drag a new item onto the canvas, if you have to insert a node at the top of your tree, you've changed the shape of the tree, so React has to actually unmount and remount that entire tree. So that's not going to work. And even if that wasn't an issue, you've introduced this coupling between the leaves of the tree and the root of the tree. And that's kind of disadvantageous because it makes it a lot harder to code split. Like, what if the leaves are coming from plugins? You have to know what plugins you're going to need all the way when you're rendering the top of the tree. It would be much easier if those two things down at the leaves could just cooperate with each other without involving their ancestor at all. And so the way that we solve this type of problem with Recoil is, I think of it like taking this entire React tree, we're just going to lie it down on a table. Okay, so this is the React tree and it's lying flat. And then we are going to enter the third dimension and create another tree orthogonal to the React tree, floating above it in space. And we're going to have a piece of state for each of these items that we had on the canvas, floating above our React tree. And the first piece of state, when it changes, we're going to re-render the first item on the canvas, the first item on the list, and then the second, third, and so forth. So each item is just going to, each piece of state is going to have its own individual components re-render when that state changes. Okay, that's the basic idea. We need a name for these pieces of state. We're going to call them atoms. So an atom is a changeable, subscribable unit of state, okay? So let me just show you how this code works. I'm going to do the simple case first, which is background color. So here I've got this background color picker component, and I've got the backdrop on the canvas. When I change this background color, I want for only those two components to re-render and not anything else that's in the tree, so that I get this nice, smooth change in background color. That's a good color. All right. So this is the picture. We're going to have this background color atom, and then it's going to be connected to these two particular components, which will re-render when it changes, and nothing else in the tree is going to re-render. So here's this app component that we had before up at the top, and we just need to make a very small change. We're going to add this Recoil root component. It's just a context. Everything that you see in Recoil is going to be scoped to that. You generally just want one in your app. Now let's look at the two individual components, background color picker and canvas backdrop, that we want to be in sync. So currently each of them has their own component local state. They have color, set colors, use state, okay? And so currently they just are separate pieces of state. We want to make it so it's the same state between the two components. So we just need to make a couple changes. We're going to import something called background color from another module into both of these. So they have a reference to the same thing called background color. And then where we have use state, we're just going to change that to a new hook. Use recoil state, and we're going to pass in the background color, which is this thing we imported from the other module. Once we've done this, both of these components have local state, but it's the same state, okay? And they're going to be sharing their state with each other. Now, you could think of it as if it was React local state, but suppose the two components had refs to each other, and whenever you called set color on one, it would just sneak over and also call set color on the other, all right? So the semantics of batching, scheduling, all that stuff works exactly the same as React local component state, but it's shared. So what is this background color thing that we imported from that other module? So that's the atom that I was talking about earlier. So we're just going to define that. We call atom, and then it just needs a couple of options. It needs a unique key, and just like React state, it needs a default value. Once we have that, those are the only changes we need to make so that we get this nice synchronized thing between these two components. Okay, so I'm going to now do the harder case where we have an indefinite number of atoms, one for each item that's on the canvas, which is the thing that you can't easily do with React context. So you'll notice that each of these items has an ID. We have that ID array up at the top of the app. And what we want is for a different, basically we want a different atom for each of these. So let's just make a function that takes an ID and returns an atom. So when we call that function, we'll have the ID of the item we want, and then we'll get the atom for that item, okay? So each item will have its own atom, its own state. So it just needs a couple of options. We'll put in the default, whatever default value should be for that state. And then we just want one atom for each ID, so we'll just memoize that function so that we're just producing it the first time we see that particular ID, and then we'll keep reusing it. And we'll export that. We'll call that item with ID. So item with ID is a function that takes an ID for a particular item and it returns the atom, the piece of state for that item. Okay, so we'll have to hold on to that. Now going to the canvas item component that we saw before, which had the local state with the XY position and so forth, we're just going to change that from use state to use recoil state item with ID. Okay, and that's the only change we need to make. And now we have this picture where we have lots of different components, and they each have their own piece of state. I'm actually just going to go in here and turn on the, have it highlight updates, highlight renders. Okay, and so now you can see that when I drag this around, only that individual component is rendering, the corresponding thing over on the left is rendering, the inspector over here is rendering, but nothing else in the tree. These components are not re-rendering. And I can just add, any number of things. You could have thousands of things in your tree, and it's 01. It doesn't care. It'll still go at the same frame rate that it was going at before, at least as far as this layer of things. You'll obviously have to optimize your browser compositing and all that kind of stuff, but we can't really help you with that. So let me turn that back off. We don't really need that anymore. So that's the first thing that we address with Recoil, this very flexible way of being able to keep things in sync and having shared state between components. You might notice that we still have in the app that list of IDs, and you might say, well, that's still linear time. You have to, when you insert, that's going to be linear time, but it doesn't have to be a list. You could make a tree. You can actually build any data structure you want out of atoms, and it'll have this, subscriptions will flow through that data structure, and so you could have login insertions if that's what you need to do. Very, very flexible, simple building block that you can do a lot of different things with. So the second issue, derived data. Now, what do I mean by that? I'm just going to reset this here. By derived data, I mean things that are computed from state or related to some state in some way, but can't independently vary. So for example, when I select one of these items, let me change the background color so it's easier to see, it gets this selection blue box highlight around it. And if I select multiple items, then I have this bounding box that goes around all of them. Okay, and I need to compute the dimensions of that bounding box, basically. And when I move one of these selected items, I need to recompute that. But when I move one of these other items, I don't need to recompute it. So I just need to recompute it when something that actually affects it would change it. Now, what you don't want to do here is have that be its own state. You don't want to have state for the bounding box dimensions and location, because then you have to keep it in sync with the stuff that it depends on. And that's where I think a lot of people get themselves in trouble, where you have sort of interdependent state. Then you need a reducer to make sure that whenever you update one, you also update the other. You end up with a lot of ceremony around updating your state, and there's a lot of potential for bugs. It would be much better if we just computed the bounding box as a pure function of the things that it depends on. So like bounding box is some function of what things are selected and where those things are. But then the question is, how do we efficiently recompute that function and only recompute it when we need to, as opposed to like every time anything changes? So in Recoil, we have something that lets us do that, which is called a selector. Selector is basically a pure function plus information about what state it depends on, so that when that state changes, we can recompute the function and re-render any components that depend on it. So we're just going to build that for the bounding box. So the picture will look like this. I said that this is actually a tree that's orthogonal to the React tree, and we're starting to see that, where we have this, it's actually a graph. And it's going to depend on some selection atom that says what items are selected, and then the state for those particular items. those are all going to go into this bounding box selector, which is then going to go down to some component that's going to render the blue box. And so let's look through code for that. First of all, we're going to have a selector, and the selector has this get, which is what is called to compute the function. And get will have the ability to pull in the state of other atoms or other selectors. And so first we're going to get the selection, like what IDs are selected. So we're going to just say get selection atom. That's some atom which says what IDs are selected. We're just going to get its value. And let's say that it's 3 and 4. We need to get the state of item 3 and item 4. So we're just going to iterate over selected IDs and map it to get item with ID. That's the function from before, so that returns an atom. We're just going to pull in specifically the atoms that actually affect the bounding box given the current selection. And then we're just going to compute the bounding box based on that information that we got. What happens when we do this is once we use this from a component, it's subscribed to just those atoms. So if you changed some other item, it doesn't recompute the function. Only if you change one of the things that we actually call get on, does it recompute. Which means that this is actually a lot more flexible than hooks because you can call them in loops, you can call them conditionally. The shape of that graph can change. Although it's not crazy because it's a pure function of the atom state as long as all your selectors are pure functions. So that allows us to compute this bounding box. It'll never fall out of sync. We can still just get and set the locations of the individual components. We don't have to use any fancy stuff to do that. We just set it to whatever we want. The bounding box will recompute if it needs to. Very, very simple. Now, the next thing we're going to do with selectors is actually interpose a selector in front of each of these atoms in order to enforce a constraint on the state. So I'm going to pull out this other type of component, which is a photo. And you'll notice that when I resize it, it stays in the same aspect ratio. So I can't make it like really skinny or anything like that. It just stays in the correct aspect ratio as I resize. Okay? And so we're going to just add that functionality here without changing the UI components or anything like that by putting a selector in front of each of our atoms that makes sure that that's true. So remember how we had item with ID that was an atom, like it's a function that returns an atom for each ID? We have a function that returns a selector for each ID. We're just going to change the existing export item with ID to be a selector. It's going to get some private state for the corresponding ID, and then it's going to apply some constraints, like if it's a photo, then the aspect ratio has to be constant or something like that. Once we've done that, we have to make no changes whatsoever to canvas item because the interface for getting a selector is identical to the interface for getting an atom. So we can still just use recoil state, item with ID. We can add this functionality without changing our components at all. So it's very, very powerful. You can take something that you originally modeled as state, and you can say, oh wait, I actually need to compute the value of that, and just change it to be derived without changing your components or changing a bunch of your code. Really good for moving fast. Now, there's one more thing that selectors can do. You can have this graph of selectors, coming down from your state down to components, and any node in that graph can be async. So you can take, I've got a chart component, and when I drag this out, you'll see that it's retrieving information from the server before it actually knows the width and height of the chart. So I'm just going to pull this out, and we just get a spinner. And then once it knows the width and height for that particular chart, it's going to render it out, and each one can be a different width. And so we've actually taken something that was originally state, that was just materially stored in our app, and said, oh, actually, not only do I need to compute this, I need to go to the server to compute it. This is very, very, very powerful. You can take something that was state, you can then make it derived. You can then say, oh, I need to do that in a web worker, I need to do that on the server, or vice versa. You can pull something in from async and make it synchronous, or even conditionally asynchronous. Like something could conditionally be synchronous or asynchronous. You do all that stuff, super flexible. Recoil guarantees that you won't have any race conditions or anything like that when you're using asynchronous code because we still model it as pure functions. So like that selector is supposed to be pure, except it can go to the server to evaluate the function. But if you see the same inputs, Recoil will always give you the same outputs and will always just do one request for each input value that's seen. So you don't have to worry about like race conditions. If you move away from a state while a request is happening, we take care of all of that. So all you have to do to use it is just return a promise from one of these selectors. And we do the caching, all that stuff for you. Super, super simple and powerful. So the third thing that Recoil provides is app-wide observation. Now you might notice in this demo that up in the URL, I have this document ID, and every time I change something, that document ID increments. There's a component in here that is listening for all state changes across the app, and then it saves the entire state and puts the ID for that thing that it saved in the URL, which means I can like copy this and send this URL to a colleague, and we'll just give that a minute to load in the background, but they will see the same state that we were looking at because we've saved it and we've put it in the URL there. Very simple functionality to sort of do anything that's dependent on observing all state changes, whether it's time travel debugging or persistence, that kind of thing. And we just provide some hooks for that. You can use transaction observation, and you'll be notified whenever a React commit happens that was caused by a Recoil updating, and you'll get the like which atoms were modified and that kind of thing. So I go here and we're looking at that same document. Now you can then attach metadata to each atom, so you can provide whatever settings are relevant to you as far as, do you want that atom to be persisted? Do you want it to activate the back button? Or, you go crazy with that. And there's one more thing you can do. You can actually work with state snapshots. So I have this preview button here, and when I click it, it like hides the toolbars. So now we're like previewing what's there instead of editing it. And I can just click that. It's a very fast client update. But you'll notice when I hover over it, that's actually a link. And it goes to this URL where preview is true instead of being false. So I can actually just open that link in a new tab. And when this tab opens, preview will be true instead of false, and I'll be in that other state. So you can do a lot of really powerful stuff like that that not a lot of single page apps do because it can be pretty tricky. With Recoil, we make it very easy. So you can actually build for yourself out of the building blocks we provide, something like this link component, where instead of an href, it has a state change. I'm going to like set preview mode atom to true. Then when you click the link, it just does this. But it also renders out a URL that corresponds to the state that you would go to if you executed this. And so in this background tab, I'm now in preview mode. Really powerful stuff like that. So anyway, go check it out. recoiljs.org. Now we're putting this out in a very, very early state. It is experimental. It's not sort of a very officially sanctioned type of thing, and we're still learning the ropes when it comes to open source and how to make that work. But if it's something you're interested in, kick the tires, and we'd very much like to get your feedback. I've got co-authors. Douglas Armstrong is one of the most amazing people I've ever worked with. Christian Santos does a lot of the async stuff on Recoil, also made the website and docs, which are very cool. And so yeah, I hope you check it out. One other thing I wanted to mention is that the API of Recoil is designed to be compatible with concurrent mode, which has been a real challenge for other state management libraries. We're not quite there yet, but we have a definite plan working with the React team to be concurrent mode compatible in the very near future. So yeah, that's about it. Thanks so much for listening.